Hello everybody, welcome to this talk titled Pristine-lfs, a robust replacement for pristine-tar by Andrej Shadura. Andrew has been an active DD since 2013 and maintains around 250 packages in the Debian archive. He's active in the Python, Java, and Rust teams. Besides, he also likes to package some random but interesting things. So let's hear him out.
Hello and welcome. My name is Andrej. I work for Collabora, and in this talk I'm going to tell you about pristine-lfs, a replacement for pristinta. I've mentioned this a couple of times in my previous talks already, but I've received some questions about this tool, so I decided to dedicate a whole talk to it. So I'd like to start with a little bit of history to explain why this tool is needed. At Collabora, we developed a Debian derivative called Apertis. It's built for embedded usage. It was originally based on Ubuntu and bits and pieces of Debian, and now a custom software and frameworks. In 2018, it had about 2,000 packages, source packages, which we built in open build service for AMD64, ARM64, and ARM-HF. We originally only used Git or Git-based workflows for select packages only, mostly packages we developed ourselves or packages like systemd and the kernel. Basically packages where we did some significant development and we wanted to keep changes tracked in Git. For the rest of the packages, they were stored in open build service using its built-in versioning system. In 2019 came the big change. We decided to move to Debian to stop being a derivative of a derivative. This made the maintenance easier. It also allowed us to review and reduce the delta we had to both Ubuntu and Debian because it was spread across all packages we had. It was quite difficult to track it all down. We also decided to import all packages into Git and make it the primary source, generating source packages directly from it. We also moved away from Cgit, a very primitive web interface for Git, and Fabricator, which we use for code reviews, to GitLab. This made it possible to enable CI for all packages. For those who don't know what CI is, continuous integration. So we were able to enable it for all packages in Apertis. Before that, we only used Jenkins for those packages we already had in Git. And we also used Lava, which ran integration tests on complete operating system images. Now with GitLab CI, we are able to enable CI on each and every package we have. We mostly use it though for testing the packages actually can be built and also for license compliance purposes. So, Open Build Service, which I mentioned previously, it was originally developed by OpenSUSE. It was called OpenSUSE Build Service. It's a web service which combines package building infrastructure, a bit like as built in Debian, with GitHub sort of like web UI for project management, and some review tools. So users can fork packages, change them whatever way they like, build them without affecting the main distribution, and then submit the changes for review, where they can be merged or rejected if they are not of good quality enough. However, the review tools in OBS, they work best with RPMs or RPM-based workflows, where the source package is composed or consists of a tarball, a text spec file, and possibly a bunch of patches next to them, all uncompressed. In Debian source packages, we have a tarball in which there's the Debian packaging and the upstream tarball, or maybe many of them, and OBS cannot look inside of those Debian tarballs. Sometimes it can, but not always. So during the reviews, it basically ignores the content. It shows that, well, this tarball was removed, this was added, and that's it mostly. So it's not very useful for reviews, or it's not, the history tracking is not very good in it either. So when something was changed in the past, we probably are able to find the revision which introduced the change, but it's difficult to tell what exactly the change was because it's mostly not shown. Branches in OBS are implemented in a way a bit like in Subversion. So when a user creates a new branch, it basically creates a new project linking to another project, or a new package linking to another package, the original one. And the first entry in the history is, oh, this package has been branched. So if the original package or project was removed, it's not possible to see in the past and see the history of the package anymore. So on those screenshots, you can see a typical example of a package which has the history which begins with branching. On the right, there's a typical diff OBS shows for packages. In this case, as you can see, it was able to look inside of the Debian package in tarball, but only because the version of the package didn't change. So it was able to tell that this package indeed has some changes inside. But if we change the revision, the name of the tarball would change as well. So OBS would completely ignore it and just show that, oh, there's a new tarball. So it's quite suboptimal, as you can see, and moving to Git was a huge benefit for us. So we started doing initial tests of importing everything into Git. We decided to use the 14 branching scheme, which was proposed by Rafael Herzog 6 years ago now. It was revised twice since then. It builds on basically Git build package workflow, adding namespaces for multiple upstream releases, Debian releases, derivatives, and so on. We decided initially to store tarballs using pristinta. Why this is useful? We want some guarantees that the tarball is actually coming from the upstream, hasn't been modified in between. So storing tarballs is good for reproducibility, for paper trail basically. And it's also useful to tell that we do or don't have any changes compared to the same packages from Debian. So in this grand scheme, OBS would just build packages and everything else would be in Git. So this is how Deb14 looks like more or less in Debian. There's the branch for upstream sources, a branch for the upstream sources combined with Debian packaging. Each upstream release gets its own tag. The same goes for Debian package releases. This is the aperted version of Deb14. You get another branch for each release. In this case, it's a pre-release of 2019. Each package version in aperted gets its own tag with our own suffix added sometimes. So when we don't have any changes, we just reuse the Debian package version. If we have some local changes we need to apply, we add another incremental number. So we started hitting huge problems with pristinta during the initial import. Sometimes pristinta would fail to import the upstream tarball. As you can see, in this case, it's executils, which is itself an exec tarball. In other cases, it would fail to reproduce the tarball, or it would sometimes reproduce it with a different checksum. In this case, it fails altogether. As you can see, it would print lots of errors and fail ultimately. So after fighting with this for quite some time, we decided it's not a very good idea to continue, and we need to somehow replace pristinta. So why those things happen? First of all, pristinta needs to be able to reproduce the output of every tar version ever used for tarballs, for packages in Debian. These days, there are not many formats of tar. In the past, there were different historical versions of the format. It's already not a very trivial task to support all of this format, but probably doable to some extent. Compressors are worse because unlike tar versions, they changed, it seems, a bit more. So it has to be able to reproduce the output of every compressor ever used for tarballs. And this battle is never-ending, uphill battle, I'd say, because compressors change all the time, and sometimes the output changes between versions, and it's very difficult. So how does pristinta achieve this? It ships a old SUSE version of zip2. It ships another different outdated version of the same compressor, and it also ships a zlib-based gzip, which is heavily based on NetBSD's gzip. All of this is combined into something the upstream calls the Frankenstein compressor. It's not something you are supposed to use ever in your life, probably, unless you are a pristinta developer. So pristinta is a magical tool which I'm surprised works. It's not 100% bulletproof, and it can never be, because this is ultimately an unachievable goal. You can only achieve it to some degree, but as things change, you need to update pristinta all the time and not break what it previously done. And exec makes things only worse because people complained about this quite a lot. Actually, exec sometimes even the same build of exec can produce a different bit stream for a given input. So we decided to use GitLFS instead of pristinta. So it has the benefit that it stores binaries as is. There's no need to fight with all the new compressors. It's supported by GitLab, which, for example, we use in Debian for Salsa. And the protocol is quite simple and can be easily re-implemented if for some reason the implementation we have is not suitable. So GitLFS works by storing binaries in a separate binary storage next to a Git repository, both on the server, which is in the case of GitLab, and locally. So it creates an object storage inside of the Git repository where the files are put and then they upload to the server. So we decided to name the tool pristine-lfs to make it sound familiar to pristinta. Instead of Perl, it's written in Python, mostly because I knew Python. It uses the implementation of Git LFS from Git LFS upstream, so the Go implementation. It's mostly compatible in terms of options with pristinta, so you can start using it very easily. There are some differences, but they are mostly irrelevant for most workflows. And we've been testing it for 2 years in production. So how pristine-lfs stores tarballs? So when you import a tarball, it creates a special file. GitLFS basically creates a special file in your repository, a text file mentioning the hash sum of your file, the size, and the version of the protocol. In GitLFS terminology, it's called a pointer file. So basically, it tells GitLFS that the actual file is stored elsewhere, and this is the hash of it. As you can see, there are Git attributes in here. So GitLFS uses Git attributes to make sure that the users don't have to do extra actions to actually work with files. So it installs a special hook, which on checkout copies or hard links, I'm not sure what exactly it is, but it basically makes the file available in a working directory. It replaces the pointer file, which is actually stored in your Git history. When you have edited the file, for example, and you committed it, it recreates the binary object inside of the Git LFS object storage, inside of the Git directory. And when you push, it talks to the server, figures out that, oh, there's a new object, and it sends it. And the same way, if you clone a new repository and you don't have all necessary objects, you just have plain Git history, and you want to check it out, it realizes that this object is not locally available. It talks to the server, downloads the object, and then proceeds as usual. So this is more or less the mechanism of how Git LFS works. So pristine-lfs uses this mechanism. It creates the Git attributes file just for tarballs. It also allows storing signatures for tarballs. They are not using the Git LFS mechanism. They are just stored in Git. As you can see, there's the merge setting for binaries. So without this setting, Git would try to diff binary signatures, which is pointless and a bit inconvenient. So this is a more sane default to avoid diffing them. Pristine-lfs doesn't use the GitLfs hooks by default. In fact, it does the necessary manipulations with the object itself. So it commits to the pristine-lfs branch manually. This is to avoid downloading extra tarballs which you don't need. If you only need to import a tarball, you don't need to download all of the tarballs you ever imported. And this is exactly what GitLFS will do by default. So the Git hook would only work and download all tarballs if you actually try to check out the pristine-lfs branch, which you don't normally need to. So, as I mentioned, pristinta is mostly compatible with pristine-lfs, or actually the other way around. So, pristinta has some subcommands for tarball, specifically stored in its Delta protocol, which we don't need. So, those commands are not included. There was also a verify step command, which we also don't need because there's no tarball recreation. Tarballs are being addressed in Git LFS by the checksum, so it's guaranteed that the checksum of the tarball will match the checksum of the tarball stored on pristine-lfs branch. So the verify command is not needed. There's a new command, import DSC, which is just a convenience tool to automatically import all tarballs mentioned in a DSC file, just to make the life easier to save you commands and all that. So pristine-lfs is a little bit easier to use than pristine-tar because we've added some options to simplify the usage. For example, the author option for checkout subcommand automatically finds the version which you need to check out by inspecting the Debian changelog available on the current branch. So you don't actually need to list the tarballs and check out one specific tarball version you need. So you just go onto the branch with your packaging. In this case, it's Apertis 2020 Dev 1. And you tell it to automatically check out the latest one, which it does. So this is how import DSC works. You can just give it a DSC file and it sees that there's the tarball and it imports it automatically. You can also import the whole source package if you want. So if you pass the full option, it also imports the Debian packaging tarball and also the DSC file itself, and probably any signatures if you have on it, on the tarball, I mean. So this is useful for a specific workflow we have in Apertis. We want source packages to be consistent across releases, and by consistent I mean having identical checksums. So we have a shared pool of packages between releases, So we obviously want to reuse the tarballs between different releases. We want them to all be the same, have the same checksum. We want to deduplicate the pool, obviously. But if we rebuild whole packages from scratch each time, the checksums of the tarballs may change, the Debian tarball most importantly. While this doesn't happen often, it sometimes does happen, and then packages fail to propagate to repositories, and we need to manually copy them from other releases. So we've created special machinery to prevent this from happening and to ensure that source packages are the same everywhere. I'll explain how this works. So this is how branches look in a typical apparatus package. So there are the standard deb14 branches we have for upstream packages or upstream source, Debian source, and apparatus source. And there's also an extra branch for pristine-lfs information, which has the pointer files referring to the tarballs stored somewhere in the object storage of GitLab. The CI machinery takes that source of the apparatus branch, downloads the tarball from the LFS storage using pristine-lfs, builds the source package, and uploads it all to OBS, where it gets built for all architectures we support in apparatus. When the upload has completed, it takes the generated tarballs and commits them all to a new pristine-lfs source branch in the repository for the package, and pushes the branch, uploading all of the objects with it. So the next time the package is uploaded to a different release of apparatus, it's not completely rebuilt from scratch, but instead the Debian source package is checked out directly from the pristine-lfs source branch and uploaded to OBS. We could have done it differently, obviously. We could have gone to OBS and could have copied the package directly at the OBS level, or we could probably store all packages we've ever generated somewhere else. But this is the easiest way, the simplest way we came up with, and it works, and it's easy to support within pristine-lfs itself. So I've been using pristine-lfs in Debian for some time already for my packages, and I tried to also use it for some team-maintained packages, but there was a little bit of backlash because people are not familiar with it, and pristinta usually works. But I would love to see pristine-lfs used more widely in Debian because it has certain benefits over pristinta. It's more reliable, more robust. It does require server support for GitLFS, but since we use GitLab for Salsa, we get it for free. It doesn't work fully offline like pristinta because it doesn't have all information on Git branches. If you need to check out some tarball, you need to download the corresponding binary object first into the local object storage. So before going on the plane, you need to synchronize the object storage, and then you can work with the tarballs. You don't need to do that obviously with pristinta. You just need to have the necessary branches because it will recreate the tarball unless it doesn't, and the checksum is different obviously. At the moment, there's still no Git build package and integration yet. It is quite simple to create, I guess, because in any case, pristine-lfs is mostly option compatible with pristinta, so we can just copy-paste necessary lines, but there's an easier and better way. Pristine-lfs is written in Python, so its functions can be used directly from Git build package, which is also in Python. Feel free to install pristine-lfs and play with it. The code is up on Salsa, so you can hack on it if you like. I'm planning a release next week, I guess, with a couple of fixes and usability improvements. And I'd love to hear your feedback. So thank you very much for listening. I'd just like to know that we are hiring, and we, as you can see on this slide, we love Debian and we use it a lot in Collabora. And that's it. I'd love to answer your questions after the talk. Thank you.
Okay. Now let's.
Thank you for the great talk, Andrej. This was really interesting, and we have further questions from a couple of people. So I'll just read out the questions for you, and you can answer them as we go. So the first question is, how would you envision a mass migration to pristine LFS of a team that has been using pristine-tar so far?
I'm not sure what exactly would be a mass migration. I guess switch all packages from pristinta to pristine-lfs.
Yeah, I suppose, because let's say the Ruby team is using pristine-tar for like a bunch of packages, like around 1400 packages. How would you envision a mass migration from using pristine-tar to pristine-lfs? Like, how would you?
So I initially I wasn't thinking about a mass migration as such, but more of so my idea was that we don't switch all existing tarballs which work to pristine-lfs. We just start with pristine-lfs for new tarballs, and we probably keep the old ones in pristinta if we want to. So there's technically, so if the old tarballs can be checked out with pristinta just fine. As long as this works, we probably can keep them. But if we wanted to do a mass migration, probably the easiest way would be to check out all of tarballs from pristinta, check them into pristine-lfs. I guess that would be more or less 10 lines long script or something. Someone's writing. Oh yeah. Obviously, pulling tarballs from snapshots also would work.
Yeah. That way you're using the ones they match with the ones that were sent to the archive in the first place.
Yeah. That way we can absolutely show that they are actually those tarballs which we want to use.
Right. Okay, so the next question is, how can pristine-lfs be implemented in pre-existing deb packages that we have? Is the conversion handy?
I'm not quite sure. But probably the extension of the previous question. At the moment, there isn't any script to do the conversion. If someone needs it, obviously it can be written. It should be very easy to do. So documentation. Well, there's a man page which is slightly. I tried to make the man page for pristine-lfs better than the man page for pristinta, and also the same goes for the command line help. I'm not sure I succeeded, but I guess that man page is something that we can start from. But there's no more documentation except the man page, unfortunately, and this talk, I guess.
Sure. I mean, I'll just quickly link the man page here, so everybody can see the documentation. Okay, so yeah, I mean, the next question was like exactly the extension to what you answered. Is there any documentation that we can refer to for using pristine-lfs if we're building a package from scratch? Furthermore, as an extension to the above questions, is there any documentation or something that would help with the migration from pristinta to pristine-lfs? So at the moment, we have this man page, but do we have anything more other than that?
I guess the Git version of the man page is slightly better than the one you actually linked to, but other than that, not really.
Okay.
Not yet.
Okay. Not yet. All right. So we've got a bunch of more questions. Are there patches to add support for pristine-lfs in Git build package? I suppose this would help the drive adoption.
Yeah. So adding Git build package support has been a long. So it's been something I wanted to do for a long time, since basically pristine-lfs was conceived. Unfortunately, it's something I never found really time for, because so basically I run into it each time when I want to use Git build package with pristine-lfs. I have to run extra commands. I was like, okay, I need to find time for this, and so far it hasn't happened. But I guess it shouldn't be difficult, as I said, and I should find time for this one day. I didn't support into org-tar GZ. Sounds interesting. I haven't thought of that actually. But pristinta versus pristine-lfs actually is an interesting thing. So I was actually thinking about this. So right at the moment there is a switch in Git build package to enable pristinta. So my first idea was to add another switch for pristine-lfs, but then what GBP will do if they are both enabled, or should maybe we have some universal switch which allows using pristine-lfs if it exists, and if not, if it falls back to pristinta. I guess that's something to be something to think about and probably discuss with the GBP maintainer.
Cool. So the next question is, would it be possible to make pristine-tar versus pristine-lfs?
Yeah, that's what I was talking about right now, I guess.
Okay. Cool. Also, yeah, I mean, there was another point about adding support for pristine-lfs into org-tars. So the next question we have from IRC is pristine-lfs backportable to Buster?
To be honest, I thought it was in Buster already, but I guess I might have missed it. I thought it was in Buster. Let me check. It should be. No, it wasn't. It was released after that. So, yeah, obviously it is backportable. I think. Actually, it depends on Python. Depends on the version of Python we have in Buster. So I think I am using some features of Python 3.6. Yeah, it's Python 3.7 in Buster. So I guess it should work, unless. There was one issue in Buster, which we had to work around in Apertus, because Apertus is based on Buster. So we had to pull a new version of GitLFS, because the one in Buster was at that point buggy. I'm not sure. I may have backported it actually, but it was doing this thing. Is that so? When you were pushing a branch, a GitLFS branch, a branch with GitLFS objects to the server, it would try to find all of the binary blobs mentioned on that branch, and if one of them was missing, it would fail, which is a typical situation when you import a new tarball. So you check out the Git, you call on a Git repository, you check in the new tarball, so this is the only object in your local storage, and you push just to submit it. You don't want to download everything before pushing, and Git LFS would fail in that case, because it say, oh, objects are missing, can't proceed. So Git LFS needs to be backported to Buster, I guess, unless I already did that. I remember wanted to do that, but maybe I stopped when it was in Apertus already. So that's, I guess, the answer.
Okay, so the person who asked the question also mentioned that. So I checked before asking, and it's not there.
Yeah, I checked myself while talking about this. So
yeah. Also, I think the version of Python in Buster is 3.7.
Yeah, it should be fine, I guess.
Yeah.
Yeah, GitLFS is GitLFS in stable backports is more or less up to date. It should work. So yeah. So it should be relatively easy to backport.
Okay, cool. So do you plan to work on backporting this?
Yeah, why not?
Sure, sounds great. Okay, I think we do not have any more questions at the moment. We can just wait for a minute in case anybody has a question, and then we'll wrap up if there is. Oh yeah, he says that Git LFS has been backported, so it should be doable as well.
Yeah.
Okay.